Good morning, everybody. This is a live severe weather briefing as we already have a severe thunderstorm warning along the Red River region just to the east of Durant. Here you can see the latest reflectivity from the Radar Omega app. The strongest hail core with this storm is located just to the south of Boca Chica to the southwest of Bennington. Here you can see the Red River region here. And this storm has quite minimal tornado threat. Right now it's a little bit behind frontal zone, probably a bit undercut as well. You can see what appears to be a bit of an outflow dominant or elevated configuration right now to this blob of convection. Usually when you get this forward propagation too with new updrafts being developed along the leading edge of the outflow, that's a sign that this thing is an outflow dominant storm right now. Probably cold outflow associated with this thing behind this gust front. And as you can see, the loop here, you can certainly see the forward propagation. Definitely had some elevated supercell characteristics there when it was between Denison and the Durant area. Definitely some big hail as well. But you can see as this storm complex lifts off to the northeast, along its leading outflow, you get some new convective cores that will develop. Right now, the strongest core is just to the southwest of Boswell, Oklahoma, 10:29 in the morning. Central Standard Time out there. This is the severe thunderstorm warning there. And as I mentioned earlier with some of my posts, I do expect the hail potential to be greatest with this early mode of convection. And this is a very large, slight risk for severe weather. So I think there's going to be numerous modes of severe weather within this event. And right now you are just seeing the very first mode here developing into far southeastern Oklahoma. You can see a couple other convective clusters here developing over the mountains of southeastern Oklahoma, extending down into far northeastern Texas, down near the Paris area. And I do expect these to expand into supercell storms here through late morning into early afternoon, and these could extend into southwestern Arkansas as well. There is a minimal tornado threat with these storms, but I think that these storms are going to be more of the hail-producing variety out here with this initial mode down into southwestern Arkansas. Let me show you my target area that I came up with this morning, and this will show you basically where the different modes of the severe weather are going to happen geographically. Right now, we're getting this very first mode of early supercells with an isolated tornado threat. I came up with this at about sunrise this morning, identifying that window for tornadoes about 11 a.m. to 4 p.m. Those storms are already ongoing back here just to the east of Durant near the Red River region. And there is an environment that's marginally conducive for supercell storms, but one issue is back closer to this cold front. The surface winds become more west-southwesterly with time, so that's called veering. You get more westerly surface winds that are orienting themselves parallel to this convective line, basically producing straight-line photographs, not as favorable for a robust tornado threat. But if you can get some deviant storm motions to really move due easterly within that environment and peel off that line just a bit, maybe moving into this deeper wind shear just out ahead of it, then those will have a chance of producing an isolated tornado. But these storms off to the west have a more stout, elevated mix layer out here. That's why I think that the large hail potential is maximized with this early mode. So let's call this first mode of supercells. The second mode of supercells will be in central Arkansas. That'll be by the middle to later portion of the afternoon. And as these early supercells over the mountainous terrain of southeastern Oklahoma and to far northeastern Texas congeal into a complex of storms and slide into southwestern Arkansas, along the leading edge, the northeastern edge to the northeast of that complex of storms, there is a potential for some renegade supercells to form. And that environment could have some stronger low-level shear associated with it, with some more backed surface winds, more of the due southerly direction, relatively weak too, allowing there to be about 30 to 40 knots of 0 to 1 kilometer bulk shear with these storms. These storms, I think, are going to have the greatest potential for tornadoes, this second mode of supercells in central Arkansas by the middle to later portion of the afternoon, just to the northeast of the MCS. That is just now starting to come together with that first severe thunderstorm warning near the Red River, just to the east of Durant. There's going to be a complex of storms here with embedded tornado warnings, likely some large hailstones as well. And then just to the northeast of that complex, I do expect some renegade supercells to develop in central Arkansas. And those are then going to begin the process of transitioning to more of a QLCS, or quasi-linear convective system, a squall line with embedded circulations, embedded mesovortices, and tornado circulations possible. So these isolated supercells are going to become HP really quickly, probably get relatively undercut by that front as well, being a little bit removed from the strongest low-level shear just off to the southeast of them. And then I think that those supercells are going to congeal into a quasi-linear convective system. That's going to represent the third mode of supercells. But actually, the fourth mode, but actually since I put together this map, I did identify the potential for some renegade supercells in the HRRR. With each HRRR run, it seems like the threat of these renegades across western Tennessee is increasing at about 3, 4, 5 p.m. time frame out there. And with about 200 to 250 0 to 1 kilometer storm relative felicity out there into central Tennessee, a couple of those renegades could produce tornadoes as well. From a storm chaser perspective, I consider that more of a Hail Mary approach. If you were to target those renegades in western Tennessee, there's a chance that they won't come together. Relatively conditional threat there. More removed from that frontal boundary that's going to be moving into western Arkansas as we go through the afternoon. The likelihood of convection with the first, second, and third modes there from southeastern Oklahoma through central Arkansas, eventually pushing into eastern Arkansas, is more likely. But this third mode of renegades, from a storm chaser perspective, if I was heading west out of Greenville to chase this environment, this is the Hail Mary approach that I would have taken and tried to target these renegade beams across western Tennessee, maybe building into far northwestern Mississippi and to northeastern Arkansas during the mid to later portion of the afternoon. And then the fourth mode is going to develop, and that is this QLCS regime. I believe that that's going to come together here to the northeast of Little Rock, northeastern Arkansas. The QCLS will then push through western Tennessee, maybe arriving to central Tennessee by late evening toward midnight, maybe 10 to 11 p.m. There into central Tennessee. But western Tennessee, early evening after sunset, like a 7 to 10 p.m. type of a time frame. I do think there's going to be a QLCS or quasi-linear convective system, a squall line moving through western Tennessee with embedded circulations within it, with that low-level jet ramping up a little bit as we get toward evening. Those southwesterly winds over top this environment increasing to about 40 knots. And this system, storm system, is weakening, so it's shearing out and with a attendant jet streak that is surging up over top. The dominant anticyclone over the southeast, a subtropical high to the southeast of the southeastern U.S. That is strengthening and expanding west with time. But that once stout trough over the western U.S. that we were looking at yesterday is closing off with an attendant jet streak ejecting over top this ridge here. And that's creating just enough lift, too, on the synoptic scale to have a large-scale convective event with many 3 to 4 different modes of convection eventually congealing into a QLCS event by this evening. But I do think there's a threat of early supercells here, late morning into middle afternoon, with this mode far southeastern Oklahoma to northeastern Texas into southwestern Arkansas, then another mode into central Arkansas, with some isolated renegades developing to the northeast of this complex of storms moving into southwestern Arkansas. Those will have a chance of some even greater storm relative helicity in the low levels because of those relatively backed surface winds out there. And then those will congeal into a QLCS event moving into western Tennessee by this evening, maybe into central Tennessee by midnight. And there is also that conditional threat of a couple of renegade storms in western Tennessee during the middle to later portion of the afternoon, aided by some breaks in the clouds there, some low-level cape as well. But let's get back and look at that severe storm that is in progress right now across southeastern Oklahoma. And then we'll analyze the environment that this storm is in and also assess its tornado potential. Really, though, it looks like this eastern core has become dominant. Initially, this storm was outflow dominant with new convective towers, even a mesocyclone, a big hail core like this, developing along the leading edge of that outflow. It does look like an elevated mesocyclone here. Has become dominant to the east of Bennington, Oklahoma, to the west of Boswell as well. This is just a couple of minutes ago. A pretty stout hail core there. I wouldn't be surprised even to see some golf ball size hailstones with that. That does appear to be an elevated mesocyclone. The RAP model definitely picked up very well on the evolution of this relatively elevated supercell storm. Most of the strongest wind shear is out ahead of this a little ways, kind of out in this region, far southeastern Oklahoma into northeastern Texas. This storm is developing back on the front, maybe even a little bit undercut by that front as well. And then you do have some veering surface winds back between that stronger wind shear off to the southeast and that frontal zone. Just a little bit of a space here. And that's why the wind shear available to these storms right along that convective line, along the cold front, isn't going to be as great as some of the forecast soundings are showing out ahead of that convective line just a little bit. Underneath the core of that low-level jet and where surface winds are more backed, you're going to have that 200 to 250, 0 to 1 kilometer storm relative helicity. But then in this environment, you're probably looking at about 100 to 150 available to these storms. And that's why I do think that this early mode of storms in southeastern Oklahoma, the greatest threat is going to be large hail with these. Boswell, Oklahoma, you're about to get hammered by a big-time hail core here coming in from Bennington into Boswell. This elevated mesocyclone developed along the leading edge of outflow. New convection became rooted along that, and then this shifted off to the east, whereas the old hail core is still back toward Boca Chico, to the north of Boca Chico. Big-time hail core here, though, between Bennington and the Boswell area. If this storm can really turn right and move basically due east, it'll have a chance to really move into that better instability and that better wind shear. But I suspect that most of these storms are just going to move parallel to this frontal zone. They may develop some elevated mesocyclones, and that'll cause them to try to peel off that line. But you're probably just going to see kind of this forward propagating type of an appearance. And then when those elevated mesocyclones become dominant, they will have a chance of producing some big hail, just like this one is between Boswell and Bennington. Hail up to 1.5 inches officially, according to that warning statement there. That includes antlers. That warning extended well off to the east. And the fact that this supercell is moving quite rapidly tells you that it's just a little bit elevated above a shallow stable layer there. It is possible that some of these supercells could become dominant, peel off that line, and potentially become tornadic. But right now, they just have elevated mesocyclones, very broad mesocyclones in here between Boswell and Bennington. But it is enough to enhance those updrafts, enhance the hail sizes out there. I'm not seeing much in the way of low-level mesocyclones with these just yet. And I think the reason is also here is the forecast. 0 to 1 kilometer storm relative helicity by the HRRR at 21Z, which is 3 p.m. Central Standard Time. And it does show an environment conducive for tornadoes with many of these modes. That includes the third mode of renegade storms there that could develop into western Tennessee. It's a little bit more conditional than some of these other modes, but you can see that these 0 to 1 kilometer storm relative felicities are on the order of 200 out there in western Tennessee. The time is 21Z, 3 p.m. Central Standard Time. But you can also see this decent 0 to 1 kilometer storm relative felicity hanging on out ahead of these southern modes of supercells that are going to be coming out of southeastern Oklahoma. This does definitely hang on ahead of the frontal zone. The frontal zone actually catches up a little bit with this decent wind shear on the order of 150 to 200 0 to 1 kilometer storm relative felicity. So it is pretty marginal out there for these storms. But I think that a lot of these storms along the convective line are going to exist in this environment, just to the northwest of that better 0 to 1 kilometer storm relative felicity. The surface winds veer just a little bit back behind that boundary. And then I do think that along the leading edge of that convective complex that's going to form in this environment out here in central Arkansas between about 3 and 4 p.m., that's where I could see some isolated supercell storms developing just to the northeast of that complex of storms that'll be ongoing in southwestern Arkansas by the middle of the afternoon. But you could get some renegade storms developing with some breaks in the clouds and some surface heating out here into western Tennessee by 3 or 4 p.m. in the afternoon. So definitely keep an eye on that for these renegade storms within this environment. So definitely a complex, severe weather setup, a large slight risk across the area stretching across these modes from northeastern Texas through central Tennessee. So now I'm going to show you why I think that the tornado threat with these storms right now to the east of Durant are a little bit limited. Here is the latest RAP analysis showing those decreasing 0 to 1 kilometer storm relative felicity values. They were quite a bit higher, closer to 12Z, closer to 7 a.m., a little closer to sunrise. That is when you have the peak low-level jet ahead of that general trough, positively tilted trough over the western U.S. And then as we go through the morning hours, notice how that low-level jet and the associated wind shear decreases a bit with time as we go through the afternoon. Decreases quite a bit there, even into Arkansas. You can see that wind shear by about 20 to 21 Z, 2 to 3 p.m. there. In western Tennessee, a little bit of a maximum. I get my head out of there. But right now, notice how these storms are back to the east of Durant into southeastern Oklahoma within an environment characterized by very minimal 0 to 1 kilometer storm relative felicity. The strongest storm relative shear is located well to the southeast, so closer to the Architects, a little bit closer to the core of that low-level jet. But notice how it is displaced to the east of this convective line. So what will determine how significant the tornado threat is across southwestern and central Arkansas is whether this convective line can catch up to the wind shear, or if the wind shear can build back to that convective line by later afternoon into evening. I think the most likely scenario is this convective line just continues to evolve to the west of the greatest wind shear, and the upper level flow is largely parallel to that convective line. The surface winds are going to be more west-southwesterly, more of a veered direction along that convective line as well. And through all layers of the atmosphere, you're really going to have winds that are parallel to that convective line through the afternoon, late morning and through the afternoon. But you can see that this storm right now is developing just to the west of that deeper wind shear. There is quite a bit of cape, though, a maximum of cape of 2,000 there just ahead of that front. But notice how the best low-level wind shear is within these due southerly surface winds. So these surface winds here are vectors, and the way they're oriented, showing the direction the wind is coming from. Notice how they're due southerly down here in the Architects, and then they shift to more of a west-southwesterly direction ahead of the southwest and northeast-oriented front. You have a positively tilted upper level system. That results in relatively southwesterly winds from the low levels all the way to the upper levels of the atmosphere. So even though you have the strongest elevated mix layer back here contributing to decent cape values and some pretty large hail sizes up in excess of 1.5 inches, you can see that the winds definitely veer over to a west-southwesterly direction here over southeastern Oklahoma. But definitely the greatest instability right now is over southeastern Oklahoma, and that's why you're getting those big hail sizes. Plenty of bulk shear as well. Looking at the mid-levels of the atmosphere, you've got 70 to 80 knot, 500 millibar winds. So you do have quite a bit of bulk shear, despite, for the most part, those winds being out of the same direction from the surface out ahead of these storms, all the way up to 500 millibars. Bulk shear, about 40 to 50 knots, is still sufficient to generate those supercell storms. We do have a subtle surface low here near the Dallas-Fort Worth area, and that surface low is forecast to just propagate along this convective line into central Arkansas by 3 to 4 p.m. And by that time, there is a small chance that just ahead of that weak surface low, and this is that surface low moving into western Arkansas by 22Z by about 4 p.m., this is the mode that I think has the greatest chance of tornadoes in central Arkansas, just ahead of the subtle surface pressure falls. You get surface winds really veering throughout this line, even though there's a greater chance of hail moving into southwestern Arkansas from northeastern Texas out of southeastern Oklahoma. I think the greatest threat subtly for tornadoes will be in central Arkansas, where you can get those winds, surface winds, being just a little bit more backed. But even with those slightly back surface winds, you're still talking about 100 to 125 0 to 1 kilometer shear for this convective line through the middle to later portions of the afternoon. So really the wrap is showing an environment that's not as conducive for tornadoes as the HRRR, the morning HRRR, and the models last night were showing. Still, though, I do think that there's a decent chance of some HP supercells here in central Arkansas, congealing into a quasi-linear convective system, moving from northeastern Arkansas into western Tennessee. And for the Hail Mary approach, the greatest low-level wind shear is actually going to be about 2 to 4 or 5 p.m. here in western Tennessee. And if some of these renegade storms can get going out there, then there definitely is a chance of a tornado threat. But basically, you have a lot of veered flow, weakening 0 to 1 kilometer wind shear with time. You do have a decent convective line here evolving from northeastern Texas into central Arkansas, eventually becoming a QLCS regime with some embedded tornado cyclones that will pass into western Tennessee from northeastern Arkansas by later on this evening. Closer to 5 or 6 p.m. it starts to approach the Mississippi River there. Notice how the low-level jet, even though it does increase to about 40 knots, 30 to 40 knots, it is also parallel to this convective line. To really get a big-time tornado outbreak, you need a more neutrally tilted trough upstream. That'll create a more backed low-level jet, more out of the due south, probably coupled with some southeasterly surface winds, and you still get these westerly winds aloft. And it'll also give you a more north-south oriented frontal boundary, whether that frontal boundary be a dry line or a Pacific front. But whenever you get these positively tilted troughs like this, it usually results in a southwest to northeast oriented convective line. Winds will largely be parallel to that convective line, leading to convective echoes that will train over the same areas. Usually these are flooding type setups. But it does appear that if some of these supercells can turn right and move off this line, then there is a chance of some slightly increased tornado potential, especially central Arkansas, middle portion of the afternoon, 2, 3, 4 p.m., 5 p.m. And then these are going to congeal into a QLCS pattern or a squall line with embedded circulations that's going to move through the Memphis area by 7 or 8 p.m. and eventually into western Tennessee. But still, if you live in the Memphis area into western Tennessee by about 21Z, so here between these two time periods, between 18 and 20Z, so let's say 2, 3, 4 p.m. there, the models, the RAP and the HRRR are showing the potential of these renegade storms to develop. You can see them here developing into western Tennessee by about 20Z. That's 2 p.m. Central Standard Time. And 2 or 3 p.m. Central Standard Time here in western Tennessee is actually the most favorable environment for supercell tornadoes throughout this large warm sector that's strung out from southeastern Oklahoma through central Arkansas into western Tennessee. But the development of these renegade storms is pretty conditional. You don't have as much lift as you do further west of that elevated mixed layer punching in over top. The instability there with those capes getting close to 2,000 in southeastern Oklahoma. But you do still have some decent wind shear. You've got some pretty backed low-level flow this far to the northeast of the surface low as well. A little bit of a jet streak that's embedded within here, leading to some accelerated low-level shear from western Tennessee into south central Kentucky. So if any of these renegades can get going in this environment, then they will certainly have the potential of producing tornadoes. Here is the HRRR. The HRRR does show these renegade storms developing into western Tennessee. It also shows the storms that have now initiated to the east of Durant developing into a complex of storms southeastern Oklahoma into western Arkansas. And it's possible that just on the northeastern edge of this cluster into central Arkansas, near Little Rock, by about 3 to 4 p.m., there's a chance that some of these storms could have a greater potential of tornadoes than the ones that are developing right now over southeastern Oklahoma. This is the latest HRRR coming in at 21Z. See if there's any renegades that get going in this. It does, the HRRR does show some convective elements in here now, but it is backing off that these renegades mature into supercells here, but you still got to keep an eye on that environment. This is at 21Z, 5 p.m. Central Standard Time. And by this time, those HP supercells that evolved over central Arkansas are now moving into northeastern Arkansas. Everything is congealing into a QLCS pattern, a quasi-linear convective system, with the greatest tornado threat within that QLCS pattern likely associated with this little low pressure lobe that propagates northeast along that line. So northeastern Arkansas by 5 p.m. But man, is that a subtle surface low. And you don't expect a big surface low, but this is at 21Z, showing that surface low into central Arkansas. The surface winds back behind it shift more southwesterly. The surface winds just ahead of this surface low could be a bit more southerly there, and that's why I think that central Arkansas mode by about 3 or 4 p.m. Does have a chance for some renegades to develop out ahead of this complex of storms that's located over southwestern Arkansas by this time. Still keep an eye out here for renegades in western Tennessee. Photographs aren't incredible. Thermodynamically, 71/68, kind of a weaker elevated mixed layer punching in here. And look at all these winds, unidirectional, southwesterly, west-southwesterly, all the way up. Pretty straight line photographs up here, but if you can get a little bean-shaped supercell developing with this little mini curved photograph here, there is a chance that it could produce a tornado or two and have some visually stunning structure. Critical angles near 50 degrees with this east-northeasterly storm motion at greater than 40 knots. Pretty fast storm motions today, actually, with the upper-level jet streaks. Kind of have a dual jet streak structure. This one lifting through the Ohio River Valley. Some right entrance region action that could fire up those renegade storms. And then you've got the other jet streak here that's currently firing storms over south central Oklahoma. That continues to lift off to the northeast. So overall, this is going to be a pretty messy setup. It looks like a lot of the flow, especially right along that convective line, is parallel to that line. So the wind shear kind of drops sub 100, 0 to 1 kilometer meter squared per second squared right along that convective line. The greater wind shear a little bit out ahead of it, where you can also get those back surface winds, greater instability, and breaks in the clouds. So you just have a little bit of a disconnect between the storms along that frontal boundary and the greater wind shear just off to the southeast of it. Your low-level cape, 0 to 3 kilometer cape at 21Z, shows a lot more of low-level cape just sitting out here in northeastern Arkansas through the Missouri Boot Heel region. And if you're a low-level cape fan, this just basically relates to those breaks in the clouds. Interestingly, a reduction of low-level cape as we go into early afternoon there across southwestern Arkansas. Likely because these storms develop within this area of enhanced low-level cape. Those are happening right now to the east of Durant. Likely going to get some anvil debris extending downstream, reducing that cape. Meanwhile, you get a little low-level cape increasing across northeastern Arkansas ahead of the next mode. And that could allow for some of these storms to become surface-based central into northeastern Arkansas. Although not a lot of low-level shear overlaid with that stronger 0 to 3 kilometer cape. Most of the stronger low-level wind shear is displaced just a little bit south of that convective line. And notice as the convective line sags off to the southeast across Arkansas, you do have a bit of an increase in the storm relative helicity there. You also have an increase in the storm relative helicity into central Tennessee out ahead of that QLCS regime. So the HRRR even at 7 o'clock p.m. is showing some embedded supercell storms here approaching the Memphis area. Still hinting at a couple of renegades out into western Tennessee. That's with that mode, that conditional mode that we identified, and should develop into western Tennessee by 3 or 4 or 5 p.m. And then you've got a QLCS pattern all the way through central into southwestern Arkansas with some embedded tornado circulations within it. Likely just ahead of that surface low out here is the greater potential for tornadoes to be embedded within that line. That convective line crosses the Mississippi River by about 8 p.m. here near the Memphis area, down through Tunica, and then back through southern Arkansas. These are going to be the more intense storms. So this is the QLCS regime that'll probably have the greatest threat for tornadoes, extending into far northwestern Mississippi by this time. Look at that. So these definitely do have tornado potential coming into western Tennessee after dark, after sunset tonight. I'm likely going to be live doing radar breakdowns through the night tonight, so definitely stay tuned for my weather updates here. Western Tennessee, northwestern Mississippi, east central Arkansas by about 10 p.m. And then that line starts to weaken as we go 10 to 11 p.m. Approaching Nashville with what looks to be mainly a rain event, probably a lot of thunder and lightning. But the QLCS event is starting to weaken by 11 p.m. as it moves into central Tennessee, northern Mississippi. So definitely a exciting day for severe weather. Let's go back to the radar and check out that severe storm that's ongoing to the north of the Boswell area. There it is. And it still looks like this is an elevated supercell. You can kind of see the outflow likely surging out ahead of this storm, created by this big time hail out here. And as that outflow happens, when you get kind of a concave boundary that shows out like that, that usually means that the outflow is pushing out from this hail core that already dropped a bunch of hail here between Bennington and Boswell. Now that it's surging out, you're likely going to see another updraft develop out here to the east of it, just like we saw happen in the previous iteration. This will become the dominant hail core down to the south of Antlers. We'll continue to lift off to the northeast toward Rattan area. I think this hail core is probably dumping its hail right now as that elevated mesocyclone begins to weaken. And then this should become the new hail core with this cluster of severe storms. We could probably see this on the echotops. Yeah, you could start to see the increase in these echotops associated with that leading edge of the outflow. That's a new elevated mesocyclone that's going to get going. The new hail core there. You can see this old hail core starting to dissipate. So as the vertical motion associated with that elevated mesocyclone begins to subside, those large hailstones will fall out. Probably already fell out over Boswell. Boswell probably got hammered by 1.5 inch diameter hailstones. And this thing continues to lift off to the northeast. But the tornado threat, at least in the near term, appears minimal with this. Looks like we do have another echo top here developing back near the Red River to the east of Denison. That could be the next supercell in the line. Yeah, you can see a couple of these cores. This one will probably go severe warned in the next half an hour or so as it lifts off to the east-northeast. So this convective line is definitely taking shape, and this is going to become a complex of storms that eventually sags into southwestern Arkansas. The strongest wind shear is a county or two out ahead of this convective line as those surface winds veer over to a west-southwesterly direction between the frontal zone and the western edge of that wind shear. We'll have to watch and see if any of these little elements to the east of Paris, Texas can take off and mature into renegades. I don't think so, because they really require the surface convergence of this cold front to really get that convection to mature, root, and take advantage of the bulk shear to become supercell storms. We'll probably see these storms just bubble here into central Arkansas into early afternoon. And then by about 1 or 2 p.m., you'll start to see these mature into supercell storms approaching central Arkansas. But I'm not too keen on this setup overall. I probably should have chased it anyway, but I'm trying to get this rocket paper done. I'm still trying to finish my 2020 edit. Got to get my taxes done, and then once I get all those things completed, then I'll be in full-blown chase mode. But I got to get the rocket paper done. If I don't get it before full-time storm chasing, then it's just not going to happen. So I am watching these convective elements to the east of Paris, Texas, that could mature into supercell storms. Just a couple little convective elements. I suspect, though, that these are probably just kind of in that warm advection regime and will just bubble and not mature into supercell storms. Here you can see that leading hail core starting to become dominant, as we suspected, to the south of Antlers. That's how you can tell that those are just a little bit outflow dominant. See that hail core will spike up, then it'll collapse, and the next one will get going off to the east of it. There you can see it peak, ship out some outflow, and then the new updraft is starting to mature along its leading edge. And that's going to become the new elevated mesocyclone, the new hail core, to the north of Hugo, between Hugo and Antlers there, in the beautiful mountains of southeastern Oklahoma. Sasquatch country out there. I heard there's a $2 million reward if you can capture a Sasquatch down there alive. Southeastern Oklahoma. But there you can see the echo tops of that new updraft, that new elevated mesocyclone that's getting going here to the south of Antlers. Well, I'm going to keep a close eye on this severe weather event throughout the day, but that is my synopsis of this large slight risk. And it does look like this storm down near the Red River is starting to become dominant. You can look at echo tops, basically a measure of how strong those updrafts are that with the top of the storm penetrating into the stratosphere. And this one's likely going to go severe to the east of Denison. Probably will pass over a very similar area, maybe just to the southeast of the track of this first severe storm. That's starting to die out here now to the north of Hugo. So that's what we got going on with this severe weather. Thank you guys for tuning into my weather reports. Never stop chasing.